Dear students, we have seen the E2 elimination in a cyclohexyl ring. You found that there should be required special stereoelectronic requirement, and then the E2 elimination will be faster in a cyclohexyl ring. Okay, the departing group and abstracted group or participating group will be trans to each other 1-2 position. Then cyclohexyl ring gives a fast elimination, that is ionic elimination reaction. We have another example, that is the 2-amino hexanol, 2-amino cyclohexanol. Okay, when this molecule is treated with the nitrous acid, then you know that the NH2 is converted into the N2 plus, that is a diazonium salt. Okay, and in this case you found that the diazonium salt, okay, that N2 plus is arranged in such a way that, if you give the naming from there, in such a way that the carbon C3 and C2 are trans to each other. Okay, like that N2 is the trans to the bond C3 and C2. Okay, departing nitrogen, okay, this will be depart after the reaction. Departing nitrogen, okay, departing nitrogen means the diazonium group arranged like that, it trans to the carbon bond C2 carbon and C3 carbon. Okay, therefore in this case the rearrangement takes place and that bond trans to each other, it move to this towards this carbon, and N2 will be removed. Okay, then this will this bond will go there, this breaks, and you will obtain the compound is like that. Okay, for the sake of understanding purpose, I can write like that. Okay, therefore it is equal to cyclopentane carboxylidine, cyclopentane then carboxylidine, you obtain the if your NH2 is at equatorial position. Okay, now we have this is a trans isomer, trans 2-amino cyclohexanol. If we have the cis compound of this NH2, okay, there are the two types of cis compound. First, NH2 is at equatorial, and second, NH2 is at axial, and this will be at equatorial position. Okay, 2 is you have the cis 2-amino cyclohexanol compound, looks like that. Okay, both are the cis isomers. And now when you add the HNO2 nitrous acid to this compound, Okay, this you know that HNO2 convert NH2 into the diazonium salt. Okay, it get converted into diazonium salt, and in this case also it converted into a diazonium salt. And this is the H. Okay, in this case, in first case, okay, that is NH2 is equatorial and OH is that axial. In this case, NH2 is axial and OH is the equatorial. Okay, there in this case also, the NH2, that is the diazonium group, that is N triple bond N plus group, is adjusted like that. C2, okay, 1, 2, 3, C2 carbon and C3 carbon will be trans to each other. Therefore, as like the trans isomer where your NH2 is the equatorial. In this case, you obtain this bond will migrate towards this and this revert, and you will obtain the same product, cyclopentane carboxylate. Okay, therefore you found that in this molecule NH2 is at equatorial. Okay, and in this case NH2 is the at equatorial. Okay, no effect of that particular OH, whether OH is axial or the equatorial, and if NH2 is at equatorial, then it gives the same product. Remember that NH2 equatorial, whether it is axial or equatorial, it gives the same cyclopentane carboxylate product. But when NH2 is at axial position, then it is that NH2 is a axial position, and near to it there is a axial hydrogen is also. Okay, therefore for elimination there is a favorable condition is there. Both are the abstracted group and departing both are the axial, and therefore you will obtain this N2 will remove, and you will obtain like that. Sake of convenience, we have written in a chair form, but actually if double bond is there, chair form will not exist. Okay, therefore this is the keto-enol type nature is there, therefore it will revert like that, and you will obtain okay, cyclohexone is obtained. Okay, cyclohexone obtained during the when NH2 at axial 1 and it is converted into diazonium axial is there, and to this axial there is hydrogen is axial to near to this, therefore it will revert and give the cyclohexones. We obtain the cyclohexanes from, you remember that equatorial position and equatorial NH2, and if near to the OH. Okay, this reaction only happens if near to there is a OH. If 1,2 position there is a OH, and 1,2 position NH2 and OH if they are present. Okay, therefore in the axial will only give the different product, but when NH2 is equatorial, in both cases you will obtain the same product. Okay, now in cyclohexane there is also a type, that is reaction, that is neighboring group participation, NGP. Okay, in this case also there is a partial stereoelectronic situation is required. Therefore, that is the departing group and participating group, if present, trans to each other, trans and diaxial to each other, then neighboring group participation will be faster. Okay, therefore participating group and departing group, trans and diaxial to each other, then NGP, neighboring group participant reaction, is the favorable and happens fastly. Okay, if we have the example, that is a neomethyl tosylate, CH3 is there, and in this case it is there, and OTS is at the axial position. Okay, this is a new methyl tosylate, and the methyl tosylate is all group is equatorial. Okay, all group is methyl. That is a new methyl tosylate. And methyl tosylate. Okay, in this reaction we carried out in acidic acid, and it's also carried out acetic acid, and the solvolysis of in acetic acid for neomethyl tosylate is 170 times faster than this. Okay, if one molecule it's solvolysis reaction, one molecule if it is react, then 117 molecule react to this. Okay, solvolysis means the one of the solvent. Okay, solvolysis means the one of the solvent acts as a reagent. Okay, acts okay, acetic acid, let's react to the on this molecule. One of the solvent is acts as a reagent or nucleophile. This reaction is nothing but the solvolysis. Okay, therefore neomethyl tosylate in acidic acid undergoes solvolysis 170 times more than the methyl tosylate. Okay, this is explained on the basis of the neighboring group participation. Okay, because in neomethyl tosylate you found that that is a departing group. OTS is a departing group, and this is also the participating group. Okay, in this case NGP is you have to, if it is depart, the positive charge is shared by the NGP. Okay, therefore that positive charge is shared by the hydrogen. Okay, that is NGP is takes place by the neighboring group. Okay, this will attack to this and you remove. Okay, if it is removed first, positive charge is there, and that hydrogen will share this positive charge. Okay, this positive charge move to this case also and this case also. Okay, therefore we have choose the tertiary. This is the tertiary hydrogen, and tertiary hydrogen is a gives the stabilized carbocation. Remember that. Instead of this is also the trans to OTS. We use the tertiary hydrogen for the neighboring group participation. Okay, OTS will get out. Okay, remove the OTS, then that plus charge. Okay, in this like that plus charge will be appear there, and that plus charge will be stabilized by this hydrogen, and this plus charge will be this carbon also, this carbon. Okay, therefore positive. If it is moved to this carbon, it is stabilized because tertiary carbocation is the stabilized. Okay, first condition for the NGP is the departing group, and this is the hydrogen is the participating group, should be trans to each other, and mostly it should be exide, then the reaction will be faster. Okay, therefore neomethyl tosylate undergoes very fast reaction because departing group and the participating group are trans to each other, and therefore it reacts faster. Okay, then our one of the solvent, that is ACO minus, attacks on. Okay, two ways it is also attacked, and it's the second way it can be attacked to this. Okay, therefore you obtain the product like that. Okay, OAC, and in this case you obtain the product. Okay, that is OAC. Okay, the product you obtain in this case like that product is obtained. Okay, that is acetic acid OAC minus attack on this center of this center. Both possibilities there. Therefore neomethyl tosylate undergo 170 times faster than the methyl tosylate. Okay, methyl tosylate, it is at the equatorial position, therefore your departing group is not axial position. Okay, therefore the solvolysis of this is less in quantity than the neomethyl tosylate. Neomethyl tosylate undergoes the 170 times faster than the methyl tosylate. Okay, like that way we can explain. NGP is also require the stereoelectronic fulfillment. As a requirement is that our departing group and participating group should be also acyl and diacyl, then and then, that is acyl, then and then NGP will be faster. Okay, formation of epoxide. Okay, formation, next reaction is the formation of, we have seen the NGP epoxide formation. Okay, we have the molecule, that is the cholesterol molecule, and the chlorine and OH is there, and its name is the 2-alpha chloro cholesterol. Okay, 1, 2, 3 oil. Okay, oil means the your beta. It is a alpha. Okay, beta position. Okay, that alpha and beta naming we have given the according to the this methyl group. Okay, towards the methyl group it's given the beta name, and rear to the CH3 is given the alpha name. Therefore, its name is the 2-alpha chloro cholesterol beta 3 oil. Okay, this is a big molecule. There is a number of rings is there. Okay, 2-3 rings is there. Okay, there we have only shown the very small part of, for sake of convenience or understanding, very small part of the cholesterol we have shown here. Okay, the epoxide is formed in this reaction is like that. Okay, epoxide you form like that in this case. And second, it's one of the isomer we have. Okay, its name is the 1, 2. Okay, that is opposite to the CH3, therefore it is alpha chloro cholesterol 2 beta 2 oil. Okay, beta 2 oil. Okay, 2 alpha. Okay, it is a 2 alpha and 3 beta. It is 2 alpha and 3 beta. Okay. In this case, this reaction of this is the very okay, 1000 times it reacts slowly or gives the epoxidation, okay, cyclization of epoxide ring slowly than this molecule. Okay, the product is the same for this. Okay, this will attack this and you obtain the same product. Okay, in both these two isomers, product obtained is the same, but first molecule cyclized. Okay, this molecule cyclized to epoxide very that is 1000 times less than this isomer. Okay, therefore for the epoxidation there is a condition, that is our both groups should be acyl. Okay, if we take in this series is our third isomer, Epoxidation of third isomer, that is the chlorine and the oxide, and OH is also oxide. Its name is the 2 beta chloro. Okay, that is same side. CH3 chloro is the same side. 2 beta chloro cholesterol 3 oil. Oil is the alcohol. Okay, in this case, this is our carbon bearing. Okay, that is tertiary carbon. Okay, tertiary carbon bearing chlorine, and this is the carbon anode, that is alkoxide. Alkoxide, that is OH. Alkoxide COH. Okay, that is alkoxide. OH is also trans, and tertiary carbon bearing chlorine also trans. Okay, therefore this reaction also fast, and in both cases, okay, rare attack is possible. Okay, that rare attack means the chlorine is away, that is the acyl one. Rare attack is the very possible. In this case, rare attack is the very fastly happen. Okay, therefore both are the, in this case, away, but the stereoelectronic requirement is not fulfilled. Okay, in formation of epoxide also you should require the stereoelectronic fulfillment. Okay, in this chlorine and the OH group should be also trans to each other. Then the reaction will be fast. Okay, in this case, these isomer react very slowly than the other two isomers. Okay, in other two isomers you found that OH and chlorine are the acyl and trans to each other. And this is a trans. In all cases there is a trans nature. Chlorine and alcohol is a trans. But which trans you require for the epoxidation? You should require the acyl trans nature. You should require them. And then the reaction, this will be the faster. Okay, this is all about the formation of the epoxidation. Okay, epoxidation is goes faster when our both groups, okay, both the reacting group, both the substituent should be the trans acyl to each other. And also if the addition to Br2 addition for the cholesterol, okay, this is the cholesterol 2,3, okay, this is 2,3 cholesterol or cholesterol simply. Okay, you add the Br2 in cholesterol, the addition is also should be the trans. Okay, like that. The elimination, for the elimination you should require the trans nature, as like addition to the double bond in the 6-membered ring is also happen diaxyl addition. Okay, therefore when you add the Br2, diaxyl addition will be takes place. Okay, in cholesterol double bond is there and you add the Br2, it is also diaxyl addition will be there. Okay, then if you have the epoxide, okay, if you have the epoxide is there, and in epoxide if you add the Br2, okay, 2,3 epoxy cholesterol epoxy compound, okay, 2,3 epoxy compound, that is 2,3 epoxy cholesterol. Also addition to the epoxide will be trans. Okay, epoxide addition also the trans. Remember, epoxide addition also trans. Addition to the epoxide also give the trans product, as like the for the formation of epoxide, the participating group should be the trans to each other, acyl to acyl each other. Therefore, in this case, you obtain the trans product. Therefore, addition to the 6-member double bond also gives the trans diaxyl product, and addition to the epoxide also give the trans product. Okay, this is the another two reaction we have seen. I hope you get all of these reactions. Thank you very much.